In our first video, we saw that some limits were tough to evaluate directly, so we used function tables. In this video, we'll learn various techniques to solve these harder limits. Before diving into the techniques, it's important to understand why they work. Let's look at an example. Suppose we have the function f of x is equal to x cubed minus 1 over x minus 1, and we want to find the limit of f of x as x approaches to 1. Now remember, if you plug in 1, then you're going to get 0 over 0, which is not a conclusive answer. So you might think about factoring the numerator and canceling out the denominator. But there's a problem. At x is equal to 1, the function has a hole. Does this hole affect the limit at all? The answer is no. The limit concerns values around x is equal to 1, not directly at the point. So why is this important at all? Well, this shows that using techniques won't directly account for the hole at x equal to 1. Yet, since the limit revolves around that point, it won't change the limit result at all. The first is, well, the one we just covered right now, cancellation. Essentially, if you have a limit of a rational function, and if you can factor and cancel out some of the stuff, you might be on your way to getting your answer. So let's try an example. Say that you have the limit of this expression on the screen as x approaches negative 3. Well, if you try direct substitution or limit properties as we discussed in the last video, you'll get 0 over 0, which is not a conclusive answer. Now what? Well, as I said before, you can factor the numerator and cancel some terms, leaving you with the expression x minus 2. From there, it's trivial to evaluate the limit, and we get an answer of negative 5. As you can see, this technique isn't too difficult, so let's move on to a slightly more complicated technique. The second technique that we will be learning in this video is rationalization. If you see a square root and you get 0 over 0 when you use direct substitution, it's a good idea to try rationalization. Say that we have the limit as x approaches 0 of the function on the screen. We first try direct substitution as always, and we get 0 over 0. So now we look for if either the numerator or denominator has a square root in it. In this case, it's the numerator. Next, we find the conjugate of this expression with the square root term. And by the way, if the denominator has it in another example, then you would do the same thing with the denominator. Next, multiply the entire expression by the conjugate over the conjugate, as shown on screen. And then finally, use differences of squares or cancellation to simplify. Okay, finally, evaluate the limit and get our answer. Alright, so here are some practice problems using these techniques. Pause and see if you can solve them yourself. Alright, and here are the solutions. Anyways, that's all for this video. If you have any questions, feel free to email me at lowqualitymathematics@gmail.com. And let's do some more math in the next video. See ya!